All right, welcome back, everybody. Yesterday, we ended the class with the quadratic formula, and we ended after spending 15 to 30 minutes deriving this. Now, all that means, a derivation, is where does it come from? That's it. Okay, here's a couple comments we're going to make about the quadratic formula, and then we're just going to get a bunch of practice and kind of see a couple more things with it. So right off the bat, with the quadratic formula, if I give you a function, we can always find the roots. What are some other words I could use here? Zeros. Give me another one. Solutions. And the last one, Zed? Zeros, roots, solutions, x-intercepts. Now, as we go through, it does show up, and I put this on the factoring checklist, but I want to be very clear. Factoring is just a way to get to your roots. You get a factor and you set it equal to 0. That's it. If we had something equal to 0, we could just work backward and find the factor. Or sorry, if we had x equals some number, for example, if we have x equals 3. If I have this written, is it reasonable to say we could all subtract 3 from each side and get here? Here's my root. What is this piece called? It's a term. It's a difference. You're both correct. But when we factor, do we get stuff that looks like this? We get a factor and a root. They're the same thing. They're just written in a different format. Now, as we go through here, the issue that I have with the quadratic formula, and my guess as to why it wasn't approached in Algebra 1 last year, is that when we do the quadratic formula, typically, if you don't like to factor, you're going to use this for every single problem. Okay, here's the truth. I don't really mind if you use it for every single problem, but your assignment is going to take you so much longer if that's what you ultimately go with. Okay, not only that, but if you wind up using calculator and stuff, typing this into the calculator, do you think it's expected that some people are going to make mistakes? For sure. Okay, this one, the important comment that I'm going to make, a couple of them. This is a last resort. We only commit to using the quadratic formula, with the exception of a few examples to make sure we can get practice. This is a last resort for finding roots, which means if everything else in that factoring checklist has failed, then we'll commit to this. Only at that time. Now, with the exception of these next few examples, because we need to make sure that we can use it. And we'll do some nice ones that work really well first, and then we'll go ahead and knock out some other ones. So, without any further ado, let's start some examples. Okay, so for each of the following, I want us to find the x-intercepts of each of the following functions. And I know it's super repetitive, but we're just trying to get it to stick in your brain. What else could I have asked you for? The x-intercepts are 1. And the roots, the zeros, the solutions. You're going to see all 4 variations. Now, they're essentially synonyms, but I wouldn't talk about the x-intercepts of an equation. I would talk about the x-intercepts of the graph of that equation. And it's a subtle difference. For all of our purposes, they're the same thing at this point in time. So here we go. Let's start one that will work kind of nice. So let's say we have the equation y equals, I don't know, 2x squared plus 6x plus 1. I'm going to make that, I'm fine with plus 1. Okay. When we're looking at this, we're going to run through the list. Lando, very first thing that I always check if I'm trying to solve this equation. So I would work my way up to there. We certainly will check for that. I agree with you. But is there anything else that we should look at first? And you might have jumped ahead. I just can't tell. But where does our factoring always start? So hold on. Did you do the bell ringer today? Did you write down our answers? Boom. Is there a GCF here? Nope, no GCF. Is it a binomial? No. Do you know the square root of 2x squared? I just jumped to trinomial, right? I don't know the square root of 2. Not nicely, anyway. Can you guys think of factors of 2 that add up to 6? Bummer. Now, when we were doing these problems the other day, we would complete the square, right? We factored the 2 out of all the x terms, and all that works. It's fine and dandy. But do you guys agree that's kind of a long process and it takes a lot of work? So here's the good news. If we don't want to have to complete the square every single time, yesterday in class, we completed the most general possible square that exists. It says, hey, doesn't matter what a, b, and c are. If you have values for them, you can find the roots right here. We're going to do that. Now, Right now, I'm going to give you guys, like with your neighbor, I'll give you like 60 to 90 seconds. I want each of you to have this in front of you, the first couple, and you're going to look at each other or your notes, and you're going to try to recite the quadratic formula back and forth. Do it 3 times for me just to get practice. I will work once here. Check it out. Me and Perskovia, if we're partnered up, negative b plus or minus the square root of b squared minus 4ac all over 2a. Or if you're feeling like you want to sing, it's there. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Boom. There is a tune that it fits to. I don't sing that one, but I do want you guys, each pair of people, you're each going to say it 3 times. The first 2, I want you to try to look at it. See if after doing it a couple times, you can recite this entire formula. 90 seconds, go. As we get going through this, right off the bat, if we're looking for the solutions or whatever it is, what am I going to set this equal to? 0. So we'll go ahead and knock that out. So here we go. 0 is equal to all this stuff. Also, yes, this thing moves around, and I can just put it at your desks and ask you to write stuff on the board if we see fit. Okay, here is our equation that we're solving, right? Cool. Now, for this, you do not have to do this every single time, but it is helpful. I'm going to call in a couple random people, and I just want you to help me identify. In this equation, which I do think is very much written in this form, ax squared plus bx plus c, which I can see that, we can now either complete the square, or without completing the square, we can just use this wonderful formula because we've already completed the most general square possible. So check it out. Looking at this, what is a equal to here? Jose, what is the value of a in this equation? If you are struggling, that's okay. Check it out. Do you agree that the a is connected to the x squared here? Yeah. Okay. What's connected to the x squared in this problem? So what's a? Good. Awesome. A is 2. Looking at this, b for bice. What is b in this equation? 6. It's the number right here. Notice it's a positive 6, right? So 6. And c, Chetty, 1. If you can identify A, B, and C, you're through like half the battle. The other half of the battle is having the formula, right? But let's just try this out. If I don't want to complete the square every single time, we don't have to. Let's try to plug in. I know that my roots, my intercepts, my solutions, my zeros will all be found at the lovely value of x equals, and I'm going to write out the general equation one more time here. Anybody feel like you haven't memorized already? Yeah. What is it? Negative b plus or minus square root of b squared minus 4ac over 2a. All over 2a, but I agree with you. The all part, because if somebody writes this, they're wrong. Yeah. Okay, so everything over 2a. Now, if we have this formula available, which luckily, thanks to Kennedy, we do, and we have A, B, and C recognized, which, again, we do, this problem feels a lot less like math to me because we just plug and chug. It's all we have to do through here. So we're just going to pick out these values, and I'm kind of just switching colors arbitrarily here, but let's work this out. What's B? So what's negative B? Negative 6 plus or minus the square root. B is 6, so I'm going to put it in parentheses this time, 6 squared, that's b squared, minus 4 times, what was a here? 2, and what is c? 1. And all of this gets divided by 2 times 2. Now, you may look at this and think, why would you use all these parentheses? The most common mistake somebody's going to make is when we get a negative value somewhere in here. If you don't use the parentheses around all this stuff that you're plugging in, you run a pretty significant risk of ruining the problem. Because if you subtract a negative, but you forgot to do that, your problem is going to have the wrong sign, and it's going to get all goofed up in here. So as we look at this, let's just clean it up a little bit, and we'll see. It takes a fair amount of work to simplify, but if you don't like factoring or completing the square, this is probably way easier. I'm going to work up here. So check it out. Let's just clean it up. Negative 6 plus or minus, what's 6 squared? 36 minus, and let's see, what's 4 times 2? times 1. So I have 36 minus 8, and all of that gets divided by 4. Do we stop here? No. We are going to keep going until we can't go any further. Now, that requires us to simplify fractions in the end. It requires us to simplify radicals as needed. But let's take one more step forward in this. And let's see here. Equals -6 plus or minus, what's 36 minus 8? 28. And that's still all over 4. Okay, we're getting closer. It's starting to be a nicer looking expression. This one is going to be middle of the road nice. I don't know if you guys will agree that it's nice or not. But as we go through, 28. Does anybody know the square root of 28? I don't know it either. But I'm going to make a little note here. Let's clean this up or simplify or factor the 28. I'm going to say break down because that's a more natural term for me. Break down into factors and preferably with a perfect square. And I'm going to say factors with a square number. And I'm only looking at the radical right now, a square number. So we're doing this to simplify a radical expression. Anybody know a way to multiply to get to 28? 4 and 7. Is that the right combination that I needed? Ooh, is 4 and 7 the best way to break this one down? So 14 and 2 works. Which one's nicer, 4 times 7 or 14 times 2? So if you didn't say 4 times 7, I'm going to claim you're wrong, but I want to see why. And I just couldn't tell what you said. We're making eye contact right now. If you were right, sorry if it feels like I'm calling you out. If you were wrong, sorry if it feels like I'm calling you out. Cool. All right. I like 4 times 7. Why is this my preferred breakdown? It's a square. I know the square root of one of these numbers. If we had written 2 times 14, I don't know the square root of either of those. Still all over 4, and we are 1 or 2 steps away. -6 plus or minus, what comes out of this radical? The square root of 4 is a 2, so I'll take a 2 outside of that square root symbol. Can I do anything else with the 7 inside? I can't break it down, right? It's just 7, okay? All over 4. And then here, are we done? What's the only thing left we can do? What could we possibly factor and divide out? Sebastian, what's the square root of 4? Yep, I just took it outside because now it's, instead of 28, it's 2 because we took the 2 out from the square root. Okay, looking at this, there's a bunch of different ways that we can simplify this very last step. When I view it, I look at this numerator and I see these two numbers. Is there anything that they have in common? Yeah. 2. If I were to factor a 2 out of this, and you might do this faster than I do, but I'm just trying to show everything, it leaves what inside? -3 plus or minus. What would happen if it's just a 1, right? Do I need to write it? I will this one time. I don't really need to, but I will just in case it's unclear. Root 7 all over. Can I break down 4 at all? Why would I want it to be 2 times 2? What benefit did this just give me in simplifying this problem? Yeah. Now, I'm okay with that language. I really hate it, but that's okay. When you say they cancel, as long as we all understand what's actually happening, I'm fine with it. When I say cancel, why do those 2's cancel out? So if I'm multiplying by 2 up top and dividing by 2 in the bottom, which is what I see happening, I can just split it up. What's 2 over 2? 1. This is just a cancel. Sorry. I'm canceling here because it just turns into a 1. At this point, is there anything more that we can clean up? I don't think so. I would simply write -3 plus or minus 1, and I'm not even going to write the 1, the square root of 7 over 2. Now, at this point, how many actual numbers did I find? So are you saying 1 and 2 and 3 with the 3, the 7, and 2? Check it out. I definitely agree with you. There's 3 terms in this expression. But if we had a calculator handy, or if we wanted a calculator, and I typed this in with a plus sign, it would just give me a single number, right? And then if I did it again and I just used a minus sign, I would get a different number. There's really 2 answers here. It's 3 plus, -3, I'm sorry, plus the square root of 7 over 2, and -3 minus. Okay, Looking at this answer is nice or terrible? Okay. I don't really have a strong answer. I think this is a nice answer compared. When we're looking at these, you're going to be tempted, and naturally, how many of you think you're just going to use a calculator when you're doing these? I already saw one person using a calculator. Is it okay if you use a calculator? I mean, you can't really factor on your calculator, but you might use it in various places, right? Okay, if we wanted the answers, and this is both answers right now, what we have in front of us is the exact answer. And there's a time and place where the exact answer makes sense, and there's a time and place where it makes sense to type this into my calculator and get an approximate answer. If somebody ever comes up to me and says, Holloway, will you cut me a piece of wood? And I say, sure. And they say, okay, I need it -3 plus √7 over 2 inches long. I'm going to look at them like they're dumb, right? Like nobody speaks like that. Nobody works like that. Mathematically, this one is nice. What I want to do is if you don't have a calculator, you can grab one. But I want to see what do you guys get for an approximation when you type -3 plus √7 all over 2 and -3 minus √7 all over 2. Get me our approximate answers. If I want you to get an approximate answer by typing into your calculator. If we run out of the graphing calculators, I have all of these wonderful ones over here that do the exact same stuff, but don't graph. Use the divide button.
Wouldn't they just divide this one?
So it would. So there's a couple ways you can do, and I'm glad that you realized it. Check this. Now divide it by what?
Oh.
Boom. All right, Naomi, I'm going to make you say that much slower for me. Like you weren't talking to me, and I'm fine with that. But I do want to make sure we have exact, and I'll switch color here. I should have started on new line. But I also want the approximate. You did what? I'm okay with that. Can you read that number to me again?
Oh, yeah. -0.177, 1, 2, 4, 3, 4, 4, 5, 6, 7.
Okay. If you get, this is the plus version or the minus? This must be the plus. Okay. If you do the plus version of this and you get a different number, I want to figure out why. I have a sneaking suspicion that I know why. Do you get a different number? Ooh, okay. So that's a good question. I'm going to hit, let's see here. Sorry, I'm going to change the mode here.
Yeah. How do you do it backwards?
I did it wrong. I don't have to do all the way.
Not you, the 6-7 comment.
You gotta do -7 plus or minus.
So let's see, -3 plus square root of.
No, there's a D over something. D over N. Stop. Yeah, whatever. Spot time?
There we go. Yeah, I had to change some mode stuff for you. Okay, so on this one, here is what I think is the right answer, and I just verified that. I'm going to type this in. I'm going to use a fancier calculator, but for what we're doing, it doesn't matter. Okay, so as we check this out, and I don't know what I was reaching for there. Let's come here. Okay, I'm going to show you my calculator that I have up here, and I'll clear all this. I don't need to clear it. Okay, we have -3. Are we doing the, we just did the minus version. We did the plus version. I'm going to do the minus. Minus the square root of 7, and I'm going to make a mistake here, and I want you guys to help me pick it out. I do want to highlight Angel noticed the mistake right away, and that's awesome, man. Okay, if I do this, and this looks about like your calculator, right? If you ignore all the other stuff. If I do this, where did I go wrong? The only thing being divided by 2 is the square root of 7. Now, there are two approaches that we can use to get around this. The first is if you've already committed to typing all this, I will just delete these. Can my calculator tell me what this is? Boom, yep. So you don't have to use second, I don't believe. But here's my number. What do I still have to do to it? Everything, once we have it, gets divided by 2. And what I see is I get this number, -2.82288. Did you guys get the same number? So if you didn't, we're going to 2288. Gross. Okay, what number did you get? Those of you that said no. So syntax error is definitely not a number, but I'll take it. The wrong numbers that I'm expecting is negative 4.3. That's a common wrong number. For the minus, you might have gotten 4.3 if you did it incorrectly. Okay, so can I borrow your calculator? Don't hit clear. I just want to put it up here if that's okay with you. Because I know what you did. But let's check it out. So, Sebastian, do you ever catch yourself zooming out a little bit or zoning out a little bit? Okay, I would have guessed that. That sounds rude. It's not, I promise. But you'll see why I'm making this comment here in a second. And I guess I can't promise if it's rude or not, right? That's subjective to who hears it. It wasn't meant to be rude, is a better way to say it. Can anybody help me figure out what Sebastian might have done wrong on this one? What needs to get divided by 2? Everything. In your expression here, Sebastian, you only have root 7 dividing by 2. Now, if we want to fix this, if I just type in this line, and I'll go back and I'll just delete what you had, there's 2 fixes. The first, you could just hit enter. Why is there another 3? Okay, weird. Negative 3 minus root 7. There we go. Okay, so if we want to do everything, you can either just enter now and then divide it by 2 after the fact, or if I want to make sure that all of this numerator, negative 3 minus root 7, all of that gets divided by 2, if I close my parentheses, I will have grouping around the top, right? Now, this is a common mistake, and I'm not sure if it happens with the yellow ones. Is this correct right now? No, why? That parentheses is in the wrong spot. If you get to this point and you have to get it out of there, just go 1 to the right. Now if I take it and divide by 2, is this what my expression says? So here we go. I'm just going to hit enter on this, and it's negative 2.882, blah, blah, blah. If your yellow calculator, if you do this in one single expression with parentheses around the top, if you don't want to have to type it in again, if you hit second enter, it re-brings that previous line, and all I have to do is change this minus to a what? And when we do this, here it is. Here are the 2 numbers that we just found. I love these new TI-84s. They're awesome. That's a cool calculator. Okay, my guess, if you got any number wrong, is that it's going to happen when you divide by 2. Now, going through here, as we look back at the problem, which of these answers is better for math? The exact, which is here, or the approximates? Exact is better for math. For like real-world application or graphing it or anything like that, what would you rather find on the x-axis? Negative 3 plus root 7 over 2 or negative 0.17? Like, there's a difference, right? If it's pure math, don't go through any extra work. Like, no need to do this. If there's a like physical application, it's an amount of time or it's a length or something like that, then it would make sense to use the approximation. Cool. All right. Should we do another one together? Or do you want to try one on your own? All right. So this one, I'm going to give you a nicer problem. And I'm going to be honest, we do not need quadratic formula for this. But for the sake of practicing, I want you to use a quadratic formula. I'll factor it without the quadratic formula, and we'll see if we get the same answers, okay? Cool. So on B, let's see here. I want us to do the following. I want to find the zeros, the roots, the x-intercepts of the function f of x equals, let's say it's a nice one, x squared plus 5x plus 4. Okay, I want you guys to identify A, B, and C, and then plug it into the quadratic formula and see what you get. While you're doing that, I'm going to factor it the old-fashioned way. And I realize that factoring's faster, but I just want to make sure we get practice with nice values also. Quadratic formula. If you struggle with it, I would always encourage take the 10 seconds it takes to write A, B, and C if you struggle with them. What is A in this problem? What's B? And what's C? Okay, now you guys, as I was coming around, most people have an answer. There's places to make easy mistakes, especially on the calculator, but the same mistakes happen here as well, or they're possible by hand. If we plug this in right away, I don't have to factor anything, right? It's just an answer, a formula to give me my roots without having to even think about the factoring. So check it out. X equals negative B would be negative 5. plus or minus the square root. And I would strongly encourage, whenever you write these numbers, put the parentheses around it. Whenever you plug it in, we haven't seen a problem where that's going to matter yet, but we'll do one more together where it will make a huge difference if you mess it up. Minus 4 times what's A? And C? 4. And all over 2A, which is just 2 times 1. Anybody opposed to just 2? Okay. Now, easy mistakes to make in here. This is just still minus a positive number, so it's just minus in the end. I'm going to take a fairly large step here. If you want me to backtrack and show all the intermediate work, I can, but I think that on your page and up here, we'll be able to piece it together. What's 5 squared? What is 4 times 1 times 4? So 25 minus 16 is going to leave a what in my square root? 9, okay? So plus or minus the square root of 9, all over 2 still. Are we done? No, there's a couple more obvious things that we could do. And I'm going to keep writing x equals so I don't forget it in the end. Negative 5 plus or minus, what's the square root of 9? And all over 2. If you stopped here, you're not wrong, but there's some easy, nice stuff that we can still do. Our answers are both here. When I did it with factoring, here's my factoring out. How do I make this 2 answers? Yeah, so it's already solved. And I would refer to this as simplifying because we have 2 cases, right? So when we break this down, one of these is negative 5 plus 3, which what is negative 5 plus 3? Negative 2, and all that divided by 2. And I'll write it here in a second, but I agree with you. That was the plus. What's the other one we have to deal with? So negative 5 minus 3 is what? Negative 8 divided by 2 still. And if we go one step further, negative 2 over 2 is negative 1. And negative 8 over 2 is negative 4. Now, in doing this problem, again, no faster. It's actually way slower to use a quadratic formula. But here's what we came up with. If we look at what I did for factoring, I noticed, and I went through the list, right? No GCF all the way down to shortcut because I had a leading coefficient of 1. Do I get the same answers? Which one would you rather do? Quadratic formula or just factoring? Okay, you're all wrong, but I understand that idea. Like, for sure. What if I said, what are the factors? Are you looking here, or are you looking at the purple one? Or pink? I don't know what color that is. The green one for the factors? Could we get the factors from that? Instead of saying x equals negative 1, could we just add 1 to each side to make it say x plus 1 equals 0? And notice, x plus 1 was one of my factors. Like, they're both right here. It is entirely up to you. Everybody always tries to commit to using this one right off the bat. I want to do one more problem with these, and then we'll have some time to practice stuff. But I want to see if we can avoid mistakes. So last one here. Let's see here. I want f. Well, you know what? We'll go crazy. We'll call it g of x equals, let's say it's negative 3x squared plus 2x minus, just kidding, plus 4. Yep, if you can find factors of negative 12 that add up to 2, you're golden to group it. I mean, I'm just saying solve it. I'm going to leave it up to you. Cool. I'll give you guys a couple minutes. I would run through the whole list. If nothing else works, quadratic formula is your option. Cool. But let's knock this out. Like 60 seconds is enough. A, B, and C, right? X equals, what's negative B? Negative 2 plus or minus the square root of b squared is 4, because negative b always. 4 minus 4 times a, what's a? Times c. And all of this gets divided by 2a, which is 2 times negative 3. If you are very careful with your parentheses, if I multiply these 3, negative 4 times negative 3 times 4, I don't care about the number right now, but is it a minus or positive? And so if I have 4 plus some number, now I can avoid those mistakes. Our parentheses make a huge difference with this in keeping stuff straight. Tomorrow, we'll check our answers. I want you to finish this problem tonight, but come tomorrow ready to work. Maybe ready to sing. We'll see.
There's the negative in the numerator and the negative in the denominator. Should I do it?
Yes, but it depends because maybe there's not truly a negative in the numerator when we add these. So like we'll deal with that. There's some weird parts of this for sure. All right, appreciate you guys.